Before we move on toward problem number 2 in section 2.5, let's review what we mean by a linear inequality. Now remember, this section is on nonlinear inequalities, so this kind of puts things in context. Here's a typical typical linear inequality. This would be something like we did in section 2.1 of the textbook. You can solve a linear inequality more or less treating it as an equation, except for dealing with the special case with the negative in front of the x, which comes up at the end here. So I don't have to think very much to solve this. I would treat it almost exactly like an equation. I would probably subtract the 2 from both sides. Then I would divide both sides by the negative 3. Now, when I do that, I have to flip the inequality. So I have x bigger than or equal to negative 11/3. So linear inequalities, they solve much like linear equations. Remember, if you multiply or if you divide both sides by a negative, you have to flip the inequality. And there's nothing magic about that. If you're saying that negative x is less than 2, that means the opposite of x is less than 2. So that means that, for instance, a 1 would be less than 2. Well, the value of 1 that would make this work would be x's negative 1, because negative times negative 1 would make it work. So if you multiply both sides of the equation by negative 1, that means that you want x's bigger than negative 2. So negative 1 is such a number. Now, this is how things work for linear inequalities. A huge mistake that people make with quadratic inequalities is treating them as though they can solve them like equations. Nonlinear inequalities cannot be safely solved like equations. Okay? So the only way to safely do this is first solve the corresponding equation, and then use when you solve, you'll get the intercepts, and then use the shape of the graph. Quadratic functions have nice simple shapes. They're either going to be shaped like this or like this, and that will allow us to get a quick sketch of the graph, and we can use the graph to safely get the equations, the inequality solution. Okay. So here is our first. Like I said, first think of it as an equation. Which I just wrote as an inequality. So equals. Think of it as an equation. This equation is going to be fairly easy to solve because we can factor it. Also with quadratic equations, I factor whenever possible. If I try to move terms to both sides here, even though I could do it, I might very well lose one of the two solutions. Most people lose the solution x equals 0. I'm going to factor an x out of both terms there. This is actually safer. This will get me both solutions correctly. We now have a product x times, the dot is emphasizing the times, the binomial factor equals 0. So x equals 0 or x minus 5 equals 0. So that one's already solved for us. Here x equals 5. Now, plot your two x-intercepts, 0 and 5. Now, look at this quadratic equation, or this quadratic expression here. In front of the x squared, you have a equals 1. That's positive. Therefore, the graph opens up. We don't have to have a really great graph here. We just have to show something opening up. So this is going to look like almost like a smiley face. Now, the inequality says less than or equal to 0. That means below or on the x-axis. Well, this is graph which is below or on the x-axis. And these are the x's that make it happen. Remember, your solution will be the values of x. Your solution will live in the x-axis. We can be on the x-axis, so the two x-intercepts are part of the solution, and then everything in between. So, therefore, we can say 0 is less than or equal to x, which is less than or equal to 5, if you want to write it as a continued inequality. Or you can write it as 0, 5 as interval notation. So either one of those solves.